Welcome to our product launch news conference. We are introducing LifePal, your machine learning-powered health companion. This is our video presentation for the final report. Let's meet the team. I am Shengyuan. I worked on iOS part of LifePal. I designed and built two interfaces.
Hi, I'm Arkin. I designed and implemented the water and sleep recommendation interfaces, as well as assisting with general front-end development.
Hi, I'm Anthony. I worked on the back end, setting up the AWS EC2 instance, database, Django, and API endpoints.
I'm responsible for setting up the machine learning component and prediction algorithm for each of the recommendations.
All right, now let's talk about our target users. Taking care of one's health is crucial for a person's overall well-being. Basic needs such as sleep, food, and hydration must be considered to maintain good health. However, it could be hard to consider all of these things in our busy day-to-day lives. Our target users are UCI students specifically. Being UCI students ourselves, our group members all find themselves having the desire to be healthier, but often find it too time-consuming to plan out things. Here's our first persona, Josh. He is a UC Irvine third-year bio major. He is an amateur bodybuilder, and he wants to be more diet conscious. Here's our second persona, Jake. He is a UC Irvine second-year econ major. He often feels dehydrated between classes, and he wants to drink adequate water daily. Here is our third persona, Mary. She is a UC Irvine fourth-year CS major. She is very busy with assignments and work, and she wants to adjust her sleep schedule. Now, all three of these people have a desire to be healthier, yet find themselves too busy to do so. Our solution is to provide users with recommendations on what to eat, how much water to drink, and when to sleep.
Now let's get into details of how LifePal recommends things. There are three different features of LifePal: food, water intake, and sleep time. So each of them will have different recommendation algorithms. Let's first take a look at the general structure of the system. There are three major components: the interface, the server that holds the prediction algorithms, and the HealthKit that provides information about the user's health. By requesting authorization from HealthKit, the app is able to use the user's health data to make an API call to the server and retrieve the recommendation results that meets the user's needs. The first feature is food recommendations. LifePal will access real-time menu from Brandywine. Based on that menu, each food item will be scored based on the user's current activity level and other health data. Then foods that are most likely to fit the users will receive a higher score and therefore will be recommended for each meal. Also, by clicking on the recommended food items, the users can view more detailed nutrition information. The second feature is the water intake recommendation. LifePal will suggest the best water intake level for the users each day based on the user's current activity level, temperature, and health data by using the regression model built by learning from the water intake database. A progress bar will be displayed for the users, and 3 buttons will be provided for the users to log how much water they drink each time. The last feature is the sleep recommendation. By having the users provide a wake time from an intuitive time picker UI, LifePal calculates the sleep efficiencies for the last 30 days from the user's log and recommends the best sleeping time that receives the highest efficiency score. A clear data and time will then be displayed on the interface.
LifePal will not be next generation without the personalization aspect. One distinctive feature of LifePal is that it uses the user's real data collected on their devices to perform the prediction. On iOS, health data is accessible via HealthKit. Data stored in HealthKit usually come from wearable devices, such as Apple Watch. Users can also voluntarily submit data to HealthKit. LifePal will display a simple profile page for the user to enable them to see health situation in a glance. LifePal utilizes 11 different types of health data. Out of these, age, body fat, and active energy are used most common in our models. Of course, with great features comes great responsibility. LifePal respects the user's privacy by asking what types of health data they want to share first. Then, the user will have to give LifePal permission to use such data.
Alright, now let's talk about how our application suits our users' context. Since our target audience are UCI students, in order to cater to them better, the menu that our application displays is UCI's very own Brandywine's food menu. Rather than recommending just any food, we recommend food that's accessible to UCI students. Real UCI students can use this app to get recommendations for real food. As you can see in this screenshot, each one of these food items are from Brandywine's menu. Now let's do a deeper dive into how our backend gets this data. First, our server queries Zop Meals API, a student-made app for displaying UCI dining service menus. Second, once we get a response, the menu and nutrition data is saved into our own database for easy access. 3. Whenever the user wants a recommendation, their data is sent over to our server, parsed, and 4, sent to our machine learning model. 5. The return data from our recommendation is then reformatted into JSON and sent to our front end to be 6, decoded, and displayed.
Our team worked with the intention of streamlining the user experience and creating an accessible and simple interface for each component of the application. Our food recommender displays a list of recommended meals to eat in the day to meet both caloric and nutritional goals in a day. Just tap on any meal for a detailed description of the meal's nutrition facts and Brandywine labeled badges for each food item. We're especially proud of our water recommender's design for its minimalistic design and unique animations. We allow users to track the amount of water consumed in the day with 3 buttons of amounts in increasing order: mouthful, cup, and mug. As the user drinks more water, the graph will display how much water is left to consume. Our sleep recommender allows users to input a time to wake up, and with just the click of a button, LifePal will recommend a time to go to bed that accounts for general sleep patterns and as well as how much the user slept the day before.
Let's talk about our vision for a future update for LifePal. Firstly, a weekly report will be added. This report will show users their current progress, any targets they missed, and how they can improve for the next week. Secondly, we will spend more time training and tuning our machine learning models. Currently, due to time and data availability constraints, our machine learning model is not as accurate as some commercially available models used by larger companies. We can collect data through crowdsourcing and thus improve accuracy. That's it. Thanks for coming to our product launch event.